Picking up in BC Calculus, we almost wrapped up our last problem on the last video, but just missed out at the very tail end. We were solving this differential equation, and what we wound up realizing is that when you're doing that, you're going to have to solve for what y is. And they're giving us an initial condition so that we can find a constant. Now, y prime is dy dx. We talked about separating the variables, multiplying both sides by dx, and then integrating. On the left side, the integral of 1 dy would just be a y. The big question is, should we include a constant? We're going to not do that. I'm going to talk about that issue in just a moment. But remember, we were talking about integrating for e to the 2x, and we even did this on the video. Just wanted to reiterate what was happening. We certainly can do a u substitution. We could let u equal 2x and work that out. We could even separate into two different integrals and make two different u substitutions. That being said, a u substitution really is used to reverse the chain rule. And honestly, at this point, what we are really dealing with is we've got this issue of undoing the chain rule. If we took a derivative of e to the 2x, of course, we'd get e to the 2x multiplied by the derivative of the inside, we get a 2. If we're reversing the chain rule, we're not going to multiply by 2, we're going to divide by 2. And that's exactly what's going to happen. Now, you can double check that you're right very quickly by taking the derivative. You'd get e to the 2x, and then out comes a 2, and that 2 would cancel down below. Likewise, we can say plus e to the negative 2x. The chain rule, by taking a derivative, would multiply by a negative 2. To save us some time, we can just divide by that negative 2. Now, I do want to talk about the constant issue. So very often, kids do worry about that constant, and they'll say, well, my word, I want to put a constant on the left side. We could call that C1. We could have a constant on the right side. We could call that C2. And we definitely could do that. But at the end of the day, please realize you'd have a constant on the left side, a constant on the right side, and we could just subtract C1 on both sides. And then a constant minus a constant is going to be a constant. So what we're really getting at is you don't need to write two constants. Generally, as we're solving differential equations, we're going to make our lives easier, and we'll just write a constant on that right-hand side. Now from here, we just need to find what C is. And this is where that initial condition is going to hold true, that y is equal to 4 when x equals 0. I'm going to plug in my y is equal to 4. I'm going to plug in my x of 0. Keep in mind that letting x equal 0 here will not eliminate terms, because e to the 0 is not 0, it's a 1. So these e to the 0 powers are just 1s. So be careful with that. We really are left with 2 minus 3 halves plus a constant. And a 2 is really 4 over 2. Plus negative 3 over 2 is just going to be a 1/2. So we could combine those like terms. Minus a 1/2 on both sides. A 4 is really 8 over 2, and 8 over 2 minus 1 over 2 is 7 over 2. And then we'd have a C. So at this point, we could say y is equal to 2 e to the 2x minus 3 halves e to the negative 2x, and then plus our C. Our C is just 7 over 2. Just want to let you know that our homework is changed just a little bit. Our homework is now going to be page 435, numbers 1 through 49, every other odd, I should say, and then 77, 81, and 85.